Hey, what's up guys, it's BenBonk, and a few months ago, I released my indie roguelike game, Slimekeep. And since releasing the game, there's been one thing that has been requested for me to add far more than anything else. And that is controller support for the game. I've literally received hundreds of comments asking for this, and although I was on the fence of if I wanted to put in the effort to add it, I eventually caved, so in this devlog, I'm going to show you how I added controller support to Slimekeep. But before you hop into controller support, let me go through a few other changes that I've implemented in the game since release that I haven't covered here on the channel. So far, I've been releasing updates every week or two for the game since launch. Now, most of these updates weren't necessarily focused on adding new content, but rather on bug fixes and improving game balance, so I don't think there's a ton interesting there to talk about. However, one major update that I did end up pushing to the game announced a few things. Firstly, we had the release of the Slimekeep OST, which you guys can stream on Spotify, Apple Music, YouTube, and pretty much everywhere you get your music from. You can also now purchase the OST on Steam for $2.99 if you'd like to support the composers, and I'll leave all the links in the description below. But on the content side of things, in this version 1.1 update, I announced a rework to the game's challenge mode, so let's take a look at that. A long-standing issue I've had with Slimekeep is difficulty. Some people find the game to be too easy, some people find the game to be too hard, and some people find the game to be the perfect difficulty. Now, I would say that more people find it to be too easy than too hard, so I wanted to address this specifically. Originally, this was done through a mode in the game called Challenge Mode that would be unlocked after beating the game once. When activated, Challenge Mode would basically make the game much harder overall. Slimes would drop less currency, and there would be random modifiers each day that would add a unique challenge, such as slimes having more health for that day, or bazookas falling from the sky every few seconds. Now, I thought this challenge mode was pretty difficult, but I got some feedback that many players still found the challenge mode to be too easy, which definitely caught me off guard and made me want to rework the mode to be more scalable in difficulty and offer more replayability. So I got to the drawing board and brainstormed how I wanted to rework the system. Around this time, I've been playing a lot of Blotro and Casey's mod from Inscription, which I thought both had pretty neat ways of handling difficulty. If you don't know, in Blotro, there's a stake system where you start on white stake and move your way up to gold stake, with each additional stake stacking a new difficulty modifier onto existing modifiers. So by the time you get to gold stake, things can get quite difficult. Similarly, in Inscription, there are these challenge modifiers, where the player has to select certain modifiers, which each give challenge points to meet the challenge points requirement. I really like this system also because it gave the player some choice in how they wanted to play. Now, taking inspiration from both these games, I decided to rework Slimekeep's challenge mode using something I called chaos levels. Now, instead of there just being a random debuff / modifier each day in the game, there would be a total of 8 chaos levels, starting with chaos level 1. Chaos level 1 would require the player to beat the game with one modifier active of the player's choice, in which afterwards they would unlock chaos level 2, which requires 2 modifiers, and so on. Now, to actually create this system in-game, I scrapped the old logic from the statue in the player's hub area, and made it so that when interacting, the statue would now display this challenge mode panel. From here, the player could choose the chaos level they want to play on, but will have to beat level 1 to unlock level 2, beat level 2 to unlock level 3, and so on. Then I made it so if you hit start run, the game will display 2 modifiers that make the game harder. For level 1, the player can either have their weapon take longer to reload, or be more inaccurate. For level 2, the player can either have no more item drops from clearing rooms, or no more free chest drops, and this process would repeat. For each chaos level, there are 2 modifier options I created, so 16 modifiers in total as there is a max chaos level of 8. I won't spoil some of these later modifiers, but I think they're pretty fun, so you should totally buy the game and see if you can beat them yourself. Anyways, once I select all the modifiers for my chaos level, we can view them here, and I can just hop into a new run and see if I can beat the challenge. So yeah, that's a pretty brief overview of the new challenge mode. It took quite a while to make, but I definitely hope it's an improvement overall, so let me know what you guys think. Anyways, now moving on to the big addition for this video, let's talk controller support. As I mentioned, I wasn't originally sure if I was going to add controller support to the game or not, as I knew it would take a lot of work, but it definitely caught me off guard how many people really wanted it, as personally, I don't really play too many games with controller. So I got to work and started by plugging in my controller and running the game. And to my surprise, the game already seemed to have controller support. Kind of. Everything felt fairly natural, but I'd never configured controller support for the game, and I didn't know how to change the keybinds. I figured this was some Unity thing, but after some testing, I realized it wasn't, and right off the bat, I was stumped on how to disable this default input. But eventually, the shelf man helped me out, and let me know that this was some Steam input shenanigans that was automatically binding my controller inputs to keys, which while helpful, I had to disable so I could actually add native controller support. With that minor hiccup out of the way, I started setting up basic bindings in my input actions file in Unity. Since I'm using Unity's new input system, which isn't really new by now, I was able to add a separate control system for controllers only. This meant that I now had two control schemes that I defined, one for my keyboard and mouse by default, and one for controllers that had controller keybinds for all normal actions. And Unity's new input system works by detecting if you're either playing on controller or mouse and keyboard, and depending on what control scheme you're using, it will use those keybinds, which I specify. Now immediately, we were off to a good start. The player can move around with the left joystick, shoot, reload, and mostly everything except for aiming. Now, I didn't really think this would be a hassle at the time, but I soon realized that since the player is playing a controller, well, they obviously don't have a mouse to move around since it's tied to the operating system. And since my game uses mouse input to aim, we needed a way to bypass this. And I learned the way to do this is through something called a virtual mouse. By creating a virtual mouse, we emulate a mouse to behave like a physical mouse, but it's completely controlled by code, making it optimal for controllers. So I checked out this video from Samia, which showed me how to create one of these virtual mice. The tutorial was great, but I wish I could have said this was a smooth process. Stuff just kept breaking with the mouse for random reasons, so I literally spent days debugging and tweaking things to try to figure out the culprit. And after many long conversations with ChatGPT, I realized that I was on a very old version of the new input system, which had a bunch of bugs. So all the errors I was encountering weren't even really the fault of my code, which drove me insane, but I'm just happy I got that fixed, as I was close to giving up. But now we had our virtual mouse, and I can move it around like my regular mouse with the right joystick. This mouse would now allow the player to actually aim, as well as interact with the UI in the game. So with that road bump out of the way, it was time to move on to adding rebinding support. I made this separate page for controller keybinds in the settings menu so the player could toggle between their keyboard and mouse keybinds and their controller keybinds. Now, I really wish this rebinding process went smoothly, but of course there were quite a few hiccups along the way. Firstly, I realized that when using controller, they need to be controller-specific keybinds. For example, there's no keybind for shooting by default, because I don't think there really needs to be one, as the vast majority will want to use left click to shoot. But for controllers, this isn't the case, so I had to create a rebinding for that. I also had to create some custom inputs for switching weapons left and right, which aren't rebindable by default, as it's controlled by the scroll wheel, so that's a whole new action. Another hiccup was some more niche stuff behind the scenes that you wouldn't really think about. Like, for example, I have this capture gun in my game, which you can hold down and let go of. This works fine as is, but let's say I now allow the player to rebind the shoot button. Now, whenever I rebind the shoot button, I also have to rebind the shoot release button so the game knows when the player should stop capturing, for example. But I don't want to make the player also have to rebind the shoot release button, as these inputs should automatically be connected. So these types of weird interactions just took some work under the hood to get working. But after a few days, we had the rebinding good to go, and it was time to move on to adding controller glyphs to the game. See, right now, there are a bunch of situations where the game prompts the player to press a key, like to interact with something, or to exit out of a menu. And, well, it's safe to say that I don't want the player to be prompted with press gamepad/button south to interact. So to account for this, I got these pre-made controller icons from itch.io to save on time, and recolored them to fit slimekeep. And now we had graphics for PlayStation, Xbox, Switch, and Steam controllers, which was pretty cool. As for actually implementing these icons, I initially created a system which used a dictionary of these sprites to display an image to the player. So for example, if the game detects the players on mouse and keyboard, when I walk over to interact with the Sliminator, it will display press E as normal. But if I'm using a controller, it will instead display an image from my dictionary depending on the current keybind. Now, while this worked, I realized that there were many instances where I would need to not just display an image, but rather to display an image wrapped in text, which would be a pain to figure out. But thankfully, I found out about TextMesh Pro sprite assets just in time, which I somehow never knew existed. Basically, TextMesh Pro, or the text asset I use for my game, allows you to pack sprites into a sprite sheet and then render these sprites inside of text using the sprite tag, kind of like emojis. So I spent way too long setting this up for all types of controller icons in the game, and spent a bit of time creating a new system that would dynamically display the keybinds wrapped in text based on the player's current control scheme. With a basic system up and running, I then spent a very long time updating every line of code where I previously updated a piece of text to include keybinds to now use my new system. And with that done, things were feeling pretty good. By this point, I was almost done adding controller support, but I still had one major thing left to do: UI navigation. This basically meant making it so all the UI in the game could be fully navigated using a controller. So for example, if I open the pause menu, the resume button would automatically be selected, and if I move my joystick down, the game will automatically select restart, and you get the point. Thankfully, Unity has a system for implementing this with UI elements, so I started off with that, and well, quickly realized that adding full controller UI navigation would take absolutely forever, and it was being really buggy in my case, so I figured, using the virtual mouse via joysticks would hopefully be good enough, which I know isn't ideal, but oh well. Anyways, with that decision in place, I then pretty much wrapped up all the edge cases for controller support, and there were a lot of them. For example, some NPCs ask you a question in which the player can respond by pressing 1 or 2 on their keyboard, but well, if the players are in controller, then they can't do this. Also, the start screen menu is navigatable with scroll wheel or arrow keys, and again, that isn't a set keybind in the game on controllers, so that needed fixing, but yeah, I think you get the point. But after trying up all these loose ends, I figured controller support was pretty much ready to go, so I sent it off to some of my playtesters for their feedback. And I'm really glad I did this because I fixed a bunch more edge cases, as well as making some pretty important changes. Notably, I added this aim assist option to the controller settings, as inherently I think it's definitely harder to aim on a controller than a mouse. Now, if the player would like, they can increase or decrease this aim assist amount to make the combat easier or harder. And if you're wondering how this system works, basically if aim assist is enabled or greater than 0, whenever the player shoots a bullet in the game will look at all the enemies in the room. It will then calculate the distance between the angle of the shot bullet and the angle of each enemy to find the smallest angle possible. If that smallest angle is below a certain threshold depending on your aim assist amount, let's say 15 degrees as an example, then the bullet switches trajectory and aims exactly at that enemy's position. It's a subtle effect the player might not even notice, but I think it's pretty helpful and just a good option to have if the player wants it. Another big change I made was to the aiming system. Previously, the player would just shoot towards their virtual mouse, but the issue was the virtual mouse was often too slow and inaccurate to get the player to aim towards where they wanted. So I added in a cursor sensitivity slider. That helped a bit, but things still felt off, so with some great feedback, I changed the aiming system to not use this mouse at all, and instead rotate the player's weapon solely on the input from the player's right stick. This helped a ton and allowed me to disable the virtual mouse by default, only showing it when UI is active. And with that said, controller support was pretty much good to go. Except for the fact that Switch Pro controllers didn't seem to work no matter what I tried. As it turns out, even though I previously updated my input system, I still wasn't on the newest version that added support for Switch controllers and some other weird gamepads. And I couldn't update to the newest version as it requires a new version of Unity, and I'm still stuck on Unity 2019.3. So I'm really sorry, but it doesn't look like Switch controllers will work for slimekeep. There may be a way to bypass this using a Switch to Xbox emulator, but thankfully pretty much every other controller should have support. Anyways, that's how I added controller support to slimekeep. There were many hiccups along the way, but I'm happy I got it done. And if you'd like to play slimekeep for yourself, now is the time to buy the game with the Steam Summer Sale, as it's 20% off and I just pushed this controller support update out. Hopefully there aren't too many bugs associated with adding controller support, but if you are having any trouble, feel free to let me know in my Discord server linked below. Anyways, that's all I got for this video, thanks for watching, and I'll see you in the next one. Bye.